All right, Earth science students. This teaching point to calculate the origin time of an earthquake and the arrival times of the P&S waves. Alright, so I gave you guided notes. There's really not too much to write, so please just keep in mind of the steps we need to do to calculate time of origin and the arrival times of P&S waves. Alright, steps to find the origin time. Step 1, using the ESRT, page 11, find out what was the travel time. If the travel time is given within the problem, proceed to step 2. Alright, if it's not given, refer back to the steps to find the travel time. So, they may give you the epicenter distance where you have to find the travel time, which is the basics. Alright, step 2. Find out the arrival time at the seismic station. This should be given in the problem. That's usually in hours, minutes, and seconds. And then step 3, take the arrival time and subtract it from the travel time to get the answer. So we have two equations, so we can work. Actually, two equations we can work with. P arrival minus P travel time equals the time of origin. Right, because we know that it takes some time for the P wave to get there. So the earthquake is something that happened in the past from when it arrived at the station. Alright, and then same thing, S wave arrival minus S travel time equals time of origin. Same idea, right? So when the seismic station registers the arrival time of the S wave, it takes some time for the S wave to get there from the epicenter, which is your travel time. Alright, so let's do a question together. A seismic station which is 3.0 times 10 to the third kilometers from the epicenter received the P wave at 3:33 and 0 seconds p.m. in the afternoon. Okay, remember that's 3 hours, 33 minutes, 0 seconds. What was the origin time of this earthquake? Now, going back to the steps, step 1, using the ESRT, page 11, find out what was the travel time. If the travel time is given in the problem, go to step 2. Now, we don't have the travel time, so if it's not given, refer back to the steps to find the travel time. So they give us the epicenter distance where we can get the travel time. Alright, so epicenter distance is 3 times 10 to the third, which is 3,000. We're concerned with the P wave because that's what's in the problem. Alright, bring that across. And the travel time is 5 minutes and 40 seconds. And the arrival of the P wave is 3 hours, 33 minutes, and 0 seconds. So we gotta do a little time math. Here's what we do. Okay, so the P wave took 5 minutes and 40 seconds to travel 3,000 kilometers. Take the difference between the P wave arrival and the travel time. So we take the bigger time, which is 3:33 and 0 seconds, minus 5 minutes and 40 seconds. And doing the math, we take away a minute, which will give us 32. And we add 60. 60 plus 0 is 60. And we get our math. So the time of origin for this earthquake was 3 hours, 27 minutes, and 20 seconds. Alright, let's move on for arrival times. Step 1, using the ESRT, page 11, find out what was the travel time. If the travel time is given within the problem, proceed to step 2. Okay, if it's not given, refer back to the steps to find the travel time. So if they only give you epicenter distance, you can get the travel time. And usually they give you the epicenter distances for you to find the travel times. Make it a little more confusing. Alright, step 2, find out the origin time of the earthquake. This should be given in the problem. And step 3, take the origin time and add it to the travel time to get your answer. So, time of origin plus the P wave travel equals the P wave arrival time at the station. Time of origin plus S wave travel time equals the S wave arrival at that station. Let's do an example. A seismic station recorded an earthquake with an epicenter of 4,000 kilometers. If the origin time of the earthquake was 11 o'clock a.m., so it's 11 o'clock even with 0 seconds. Remember, the seconds is not there. When did the P wave arrive and when did the S wave arrive at the station? So they give us the epicenter, we got to get the travel times. So 4,000, right, for the P, bring that across, we get exactly 7 minutes. All right, so I have here, okay, 7 minutes and 5 seconds, so it's slightly above. If you had 7 minutes exactly, that's still good. Okay, since it takes time for the P wave to travel from the epicenter, you must add the origin time and the travel time together. So we have 11 o'clock. Remember, I added the seconds because it wasn't there. And it took 7 minutes and 5 seconds to get there. So we have a P wave arrival of 11 hours, 7 minutes, and 5 seconds. Now we know the P wave travels faster than the S wave. So the S wave should be a later time than 11:07 and 5 seconds. All right, let's see. So for the same station, right, we go to 4,000, bring that across, and we get 12 minutes and 40 seconds. All right, since it takes time for the S wave to travel from the epicenter, you must add the origin time and the travel time. So we have 11 o'clock, 11 hours, 0 minutes, 0 seconds. And we have 12 minutes and 40 seconds. Add the two together, and we get 11 hours, 12 minutes and 40 seconds for the S wave to travel that distance from the origin time. All right, so that sums up this presentation. After this presentation, you should be able to know how to calculate the time of origin using either P or S wave arrival time and travel times. And 2, how to calculate the arrival times of P and S waves using the time of origin and travel times. All right, guys, have a good night. And I'll see you sometime tomorrow, and we'll work with some questions for time of origin and arrival times.